Welcome back, student. Today we are going to see the next topic in automata language and computational is Mealy and Moore machine. This is one of the important topic, okay? And here we will see what is Mealy and what is Moore machine, okay? And we will see the difference between Mealy and Moore, and we will see one simple example to define what is the difference between these two. We will take one simple example also. Okay, let's start the topic. Now, before that, first we will see the application of finite automata. We have several applications based on finite automata and finite state machines. Some are given below. So here, finite automata is highly useful to design lexical analyzer. What is this lexical analyzer? You are going to learn in the next year or in the next semester. The subject name is compiler construction. In that there are different phases are there. In different phases, one of the phase is lexical analyzer. Okay, next one. Finite automata is useful for design text editor. This is useful to design text editors. Next, finite automata is highly useful to design spell checker. When, like, if you take the example of Microsoft Word, in that we can check the spelling checker with the press of F7. So in the same way, finite automata is highly useful to design spell checkers. Next, finite automata is useful to design sequence circuit design. It is useful to design sequence circuit design. So this is some of the application for the finite automata. Okay, and already we have learned finite automata is divided into DFA and NFA. Deterministic finite automata, and we completed the non-deterministic finite automata also. Okay, fine. Next, here this Mealy and Moore will come under in DFA. DFA, okay, like sorry, here sorry. So here, like first we will see the FA. FA is divided into two. One is DFA, another one is NFA. Okay, NFA is divided into two, Mealy and Moore. Mealy and Moore. So today we are going to see this one, deterministic finite automata. Okay, and here it will come like equivalence, epsilon. Okay, this we will see in the next class. Okay, right. So today is we are going to see in the Mealy and Moore. Fine. Next, in the Mealy machine, Mealy machine is defined as a machine in theory of computation whose output value are determined by both its current state and current input. In this machine, at most one transition is possible. What does it mean? Means here in this, it will depend on the current state as well as current input. In this both, it will depend. And here at most one transition is possible. Like here, as we have done in the FA, we have the tuples. So here also we have some of the tuples. Let's see what is the tuples. Here we have the 6 tuples. One is added. This one is added. Q is a finite set of state. Okay. Q0 is the initial state. Already we done this in finite automata, DFA and NFA. Epsilon is, sigma is the input alphabet. Whatever the alphabet you are going to take, that is a sigma. O is a new one. O is a new one, is the output alphabet. Okay. Sigma is input alphabet and O is a output alphabet. Next is a transition function which map capital Q, this finite set of state, cross sigma, then we will get the Q, finite set of states. In lambda is the output function which map Q cross sigma will get O. So this is a Mealy machine and this is the 6 tuples we have. In these 6 tuples, first one is a finite set of state, that is a Q. Q0 is the initial state and sigma is the input alphabet and capital O is the output alphabet and delta is a transition function which map Q cross sigma, then we will get the Q. Delta is the transition, main important thing is delta. Next, lambda is the output function which maps Q cross sigma. Okay. So this is a Mealy machine. So this is a, if you did not understand, don't worry, when we see the difference and when we solve the example, then you can easily understand. Okay. Next is a Moore machine. In the Moore machine is defined as the machine in theory of computation whose output value are determined only bits is current state, only current state. What does this mean? Here it is output in the Moore machine, the output fully depend on the current state only, but here in the Mealy machine it's depend on current state as well as current input in this both. This is a difference between Mealy and Moore. Let's see the tuples. Here also have the 6 tuples. First one is Q is finite set of state, Q0 is the initial state, okay, and sigma is the input alphabet, and capital O is the output alphabet, same as Mealy machine. Delta is transition function which map Q cross sigma Q. This is also same as Mealy, but when we go to the output, delta is the output function which maps Q0. Sorry, Q is O. Clear? So this is a simple difference between the Mealy and Moore. Okay, in Mealy it will take the current state as well as the current input, but when you come to the Moore machine, here it will take only the current state. Okay, so this is a tuples, 6 tuples. Q is a finite set of state, Q0 is the initial state, sigma is the input alphabet, and capital O is the output alphabet, and delta is a transition function which map Q cross sigma is Q. Delta is the output function which map Q is 0. Sorry, Q is O, capital O. So this is about the Mealy and Moore. Okay. So Mealy also has the 6 tuples, and here also Mealy and Moore both has 6 tuples. Here the difference, first one. What is the first one? First one is output depends on present state as well as present input. As I told here, current state, current input, or present state, present input in the Mealy machine. In the Moore machine, output depends only upon present state. Only it will depend on the present state. State is nothing but like if we have this and this, A, B, this is called state. Okay, if we have like this, then this is whatever the number you are going to write, 0, 1, 1, 1. Okay, this is present input. Clear? So this is we will take the example and we will see that. So just for reminding, this is a state. Next, if input change, output also change. Here in the Mealy machine, whenever the input is changed, if we hear the 0, then if we have 1, then definitely the output will be change here. If input change, output does not change. Yes. Why? Why? Because here it will only depend on the state. It is not depend on the input, but here it is depending on the state as well as the input. If you change input, then it will change. Like next, less number of states are required, more number of state is required. Okay. So here if it is depend on the state, then here the more number of state needed and here less number of state are required. There is more hardware requirement for the circuit implementation. When we go with the Mealy machine, we must have more hardware requirement for the circuit implementation. There is less hardware requirement for circuit implementation in Moore machine. Okay. Next, they react slower to input one clock cycle later. So it will slower whenever they react slower to input, but here they react fast to input, because here it is not functioning, like it is not depend on the input, because of that it is fast. It is depending on the input, because of that it is little bit slow. Asynchronous output generated. Asynchronous output is generated, and here synchronous output and state generated. Asynchronous means like we can say it is not sequence. Synchronous means synchronous output and state is generated in the Moore machine. Output is placed on transition. Output is placed on transition. Output is placed on state. Output is placed in state. What does it mean? Means like here capital A, small b, capital B, small a. So here in the state only we need to place the output. When we have B on 0, it will output A. So if you come to here, output is placed on the transition, so we need to place here. When it is 0, it is A. When it is 1, it is B. So here the simple example for output is placed on transition means whatever here O associate with A, 1 associate with B, 0 associate with A, like this. If it is output is placed on state means B associate with small a, capital B associate with small a, like this. And it is difficult to design Mealy machine and easy to define is Moore machine. Okay. I hope you clear about this difference. Once again I will repeat this, then it will easy for you. Then we will go for the example and that will be very helpful for you. So first is output depend on the present state as well as present input. It is Mealy machine is depend on the present state as well as in present input. Next, Moore machine output depends only upon present state. It is only depend on the state. If input change, output also change. Yes, because when it is depending, output is depending on input and state, any one of this change, input or state, definitely output will be changed. If input change, output does not change. Yes, because already it is depending on the state. Okay. Third point is less number of states are required, and here more number of states are required. Next, fourth point, there is more hardware requirement for circuit implementation. Whenever we have a circuit implementation, at that time we need more hardware. There is less hardware requirement for the circuit implementation. Next, fifth point is they react slower to input one clock cycle later. But here they react fast to input because it is not depending on the input, it is depending on the input. Because of that, it is slower, one clock cycle. A synchronous output generated, and here synchronous output and state is generated. Output is placed on transition. Output is placed on transition means it is going from capital A to capital B. Here we are placing the output, and output is placed on state. State means capital B associate with small a. Small a is a output, and this is associated in the state. It is difficult to design and easy to design by the Moore. Okay. So this is about Mealy machine and Moore machine. So now we will see one example. Let's see. Okay. So let's go to here, and here I will take one example. One example, like consider example here. Sorry. Here I am taking capital A and I am taking capital B. Capital A and capital B I am taking, and here this is first one. What is the first one? Mealy. Okay, we will go with first Mealy. So here transition, as I told you, in Mealy the output will define here. So here 0 is a label, and for this the output is small a. Next one is, I am just drawing this. 0 is a input, and what is the output? Consider B. In the same way, if A on 1, the output is small b. Okay. If B on 1, output is small a. So this is simple design for Mealy machine. Okay, and here I will draw for Moore machine. Then when you see the two example state diagram, then you can easily identify by yourself. Okay, first one here, capital A slash small a. As I told you, in Moore machine the output will be defined in the state, capital B small b. This is a input. So let's draw the same, and here it will not depend on the input, so no need of this. Same thing here, 0, here 0. Next is from B to A, the input is 1. Okay, and B on 0. So this is diagram, state diagram. So here in the diagram only you can easily identify in the Mealy machine we are giving the output here in the label, in the transition. When A on 1 the output will be B, A on 0 the output will be small a. Like this we have defined the output here in the transition in the Mealy. In the Moore we need to define the output in state only, capital A associate with small a, okay. Capital B is associate with small b. So we will do one thing, we will take one of the string we will take and we will apply operation here, how the input is taking and what the output we are getting. So the first one is like example, I am going to take string is like take the string 1 0 1 0, 1 0 1 0 is my string. Here in 1 0 1 0 let us check it out. First a, what is, sorry, I did not draw the initial state, this is the initial state, okay, this is the initial state. And here as per this in the Mealy we need to define all this 6, okay. So here go back and here Q is a and B, capital Q is A and B, and initial state is a capital A, and input is a 1 0 and the output is A and B, okay. And transition we need to do now. Let us see here, like I am performing the operation now. Here I am going on 1. First initial state, what is my initial state? Initial state is A, okay, initial state is A, fine. From A on 1, where it is going to A only, where it is going to A only, but what is the output? What is the output? Output is B. Next, when A on 0, where it is going to B, From B it's going to B, but what is the output? Sorry, when A on 1, here we need to write A on 1 is going to A on 0 is going to B. When it is going to B on 0, what is the output? Output is A, okay. Next, from B on 1, where it is going to B only, and what is the output we are getting? We are getting the output is small a. Next, from B on 0, is going to A, B on 0 is going to A, and what is the output we are getting here? We are getting the output is B, this one, okay. So here this one is the answer for the Mealy machine. So here you can see here how many transition we need to do, 1 2 3 4, and how many output we got, 1 2 3 and 4. So in the Mealy machine how many number of alphabets are there, that much output will be get, means n number of transition n is equals to n number of output we will get. Okay. Now we will take the same example, this same example for Moore machine. Let's see first. Okay. The example is 1010, and here what is the initial state here is A. Initial state is A. But here when it is taking the initial state, you can see capital A is associated with small a. So whenever we are taking this, that time we need to take the output. So what is the output we are getting here? We are getting the output here is A. We are getting the output A. Okay. Next, from A, now we need to go A on 1. When A is going on 1, when A on 1, where it is going? When A on 1 is going to 1 capital A only, capital A, and what is the output we are getting here? Same A only. Next, when A on 0, when A on 0, when A on 0 is going to be, and what is the output we are getting? We are getting the output is small b, the output we are getting. Next, when B on 1, where it is going to A. B on 1 is going to A, and what is the output? Output is small a here. Okay. Next, when A on 0, where it is going? A on 0 is going to B, A on 0 is going to B, and what is the output we are getting? Small b. Okay. When A on 0 is going to B, and what is the output we are getting? We are getting the B. Okay. So this is a example for Mealy machine and Moore machine. I hope you understand this simple logic. Remember, whenever the Mealy machine is there, at that time transition, okay, at that time the transition at the place where the output will define in the transition. Okay. Whenever we have the Moore, where the output will define? We will define in the state diagram. Okay. So here the major difference, as I told you, here when we have the n number of states, n number of transition, okay, when n number of alphabets, at that time we will get the output n numbers. Output will also get n number. And here how many transition? 1, 2, 3, 4. But we have the 4 transition, but here can you see how many output? 1, 2, 3, 4 and 5. That means when we have n number of alphabets, okay, when n number of alphabets, we will get the output is n plus 1. Okay. Here 4, so here we are getting 1, 2, 3, 4, 5. That means n plus 1. So this is the difference between Mealy and Moore. Okay, I hope you understand. Thank you. We will see you in the next class.